Convidamos agora o Sr. Roland Greil, gerente sênior de vendas da Hitachi Zosen Inova, para a sua apresentação.
My name is Roland Greil. I'm working for Hitachi Zosen Inova, which is a Swiss company belonging to a Japanese group. That's by the name. I'm in this business, waste to energy business, for almost 30 years. And today I'm acting as a sales director, active in various markets. One of them is the Brazilian market. Good morning, bom dia a todos. It's a pleasure for me to participate in this event. I will talk about how we as HZI, Hitachi Zosen Inova, can contribute in the development of waste to energy in Brazil. We are all consumers and producing more and more waste that is polluting our environment, our drinking water, the air, plastic that is flooded into the rivers, lakes, and ends up in the ocean, and is also polluting our food. Raw material is used to produce those products and also to generate electricity. In the first step, we should reduce the amount of waste that we are producing, and that what we can recycle, material that has a value, shall be recycled and serve as a raw product to generate again electricity or produce the products. From what cannot be recycled, the energy shall be recovered, and that is the solution that we can provide to benefit from the energy that is in the waste to generate electricity, and to recover materials that cannot be recovered upfront from the waste. This helps to reduce CO2 footprint, and the pollution reduces the pollution. What are HZI's solutions in this context? For the non-recyclable waste, this waste goes to waste to energy facilities, to the thermal treatment, where you, as I said before, generate electricity, heat or steam, process steam, or even cold, and recover materials that cannot be recovered upfront. Non-recyclable materials can go directly to the recycling industry. For the organic waste, we are using our CompoGas technology, that is a dry anaerobic digestion. So where the green waste, the organic waste from households, from supermarkets, from markets, from the food industry is delivered, also from agriculture, and biogas is produced, and also fertilizer, which then goes back to the agricultural industry, used in greenhouses or in gardening or in parks. Wet organic fraction is going to the wet anaerobic digestion, which is a bit more simple process actually. What do we do with the biogas? We generate electricity as well, or we do the biogas upgrading to biomethane, which then can be used as a fuel for vehicles. And for the excess of energy that is produced from our plants or from other renewable sources, we use that in our power to gas solutions. What is the context of our solutions in renewable energy? So waste energy is delivering the base load, constant production. AD, where you can store the gas, is an on-demand energy. And excess energy from fluctuating sources, renewable sources, can be used in our power to gas solutions to produce the gas, which can be stored and can be used when there is a demand. Hitachi Zosen Inova is a company located in Switzerland. We have our headquarters here in Zurich. We are about 600 people here in Zurich, working for the solutions to deliver plans to our customers. We have other locations. In total, we are a bit more than 1,000 employees, and we belong since 10 years to our Japanese parent company, Hitachi Zosen Corporation. which used before our technology as a licensee to build plants in Japan and in other Asian markets. As presented before, we have our proprietary technology for thermal treatment of solid wastes, anaerobic digestion of bio-waste, and biogas upgrade system and power-to-gas systems. We don't only deliver and build plants, we also operate, maintain, and service the plants that we have delivered. Our market share over the last 10 years was a bit above 27%. In the last years, even above 30% worldwide. That is both together our parent company covering the Asian markets, and we basically covering the rest of the world. This is all counted on capacity installed. Demands on waste to energy solutions are very high and constantly increasing. We get more and more stringent emission limits to protect the environment. We have to optimize the capex to make projects feasible. Economics of scale is a very important aspect in this context. We have to find and design efficient solutions to minimize the operating cost, increase the performance, the output of the plants for generating the maximum revenue. We design plants for a long lifetime. Plants can live for 40 years. That is typically the average lifetime such a plant can reach, and design it in a way that it can be easily maintained. Of course, health and safety is a very, very important aspect as well. So we design a plant in a way that people during construction and operation are protected. We have all steps of the technology needed to build a complete plant. First section is the combustion boiler section, flue gas treatment, residue treatment, and also energy utilization. Our technology, and I focus today on waste to energy, not on the treatment of biological waste, on the treatment of the non-recyclable waste, is a great combustion technology, which can take a wide range of different waste fractions and can be adapted to the local requirements and to local waste composition and specific situations. You see here the range of net calorific heating values. This is a very wide range, from very wet waste with low energy content to waste with very high energy content. And we can deliver plants with high capacities. So the maximum capacities where we have executed project is up to 55 tons per hour per unit for a single plant, for a single boiler, what you can see here on the picture. And the thermal capacity, that means fuel input, of 125 megawatts per line. We have also all kinds of flue gas treatment technologies, which can be dry systems, semi-dry systems, wet system, or combinations of those systems, depending on the situation, the local requirements. And also solutions for NOx reduction. Here I'm showing our advanced Dyno system, an advanced SNCR system that can reach very low NOx levels in a very simple way. This allows us to build plants in the middle of cities. What you see here is in Paris. This plant is about 3.5 kilometers away from the Eiffel Tower, which is on the right side of the picture. And this plant is 2/3 underground. So the trucks are coming here from the left, going down, tip the waste, where the waste is then thermally treated, flue gases are treated, and the gas is coming out, the clean flue gas is coming out from the stack here. We integrate the technologies that I've just presented, our proprietary technology, to deliver complete waste energy facilities. And do some engineering and conceptual design for systems that are not our core technology, such as electrical installations, control system, balance of plant system, and a water steam cycle. And in markets where we have a local presence, we also manage civil work activities. Doing it in this way, this allows us to integrate those solutions in the best way, to maximize the efficiency of those plants and guarantee a reliable execution. This also means that in new market, and Brazil is a new market for this kind of solutions, we typically team up with a local partner that has a strong local presence, good track record, and local experience. A good example is this project here. I will not show the videos. You go for YouTube, search for Rooker South construction progress, and you will see the whole construction of this plant in four phases, in four videos, building up such a plant. It's quite a complex thing. You will see that, and it takes about 3 years to build such a plant. This is a plant in UK, and where we have been fully responsible for the full EPC turnkey wrap. A very important aspect is the financing, of course, of this kind of projects. I've listed some key factors on this slide. I do not go into the details, but important is that for some of these criteria, EDICE makes an important contribution. We deliver proven, mature technology, which is the great combustion. We are an experienced contractor. You can see our references on our homepage. So only in UK, we have built in the last years 14 waste energy plants. We have a strong financial background, supported by our Japanese parent company, Hitachi Zosen Corporation. We have O&M experience, so we can provide also O&M support. And we might be able to get some governmental support from the Swiss Export Credit Agency, which is the SURF, to facilitate the financing of these projects. Over the last years, I mean, Europe was our home base, so most projects have been built in Europe. I mentioned before, UK was by far the biggest market over the last 10 years. In Europe, worldwide, it was China, where most of the plants are built on licenses from European companies, such as us. But for some plants, especially the big ones, we are delivering the combustion grades out of Europe to these plants in China. I will now show you some of our projects in new markets, in Turkey, in Australia, in Russia, and in the Middle East. One of them is this plant here. It's in Turkey, Istanbul. It's the biggest plant in Europe. It's just in commissioning. We started to thermally treat the waste at the beginning of March. And this plant is designed for quite a waste with quite a low heating value. You see the numbers here, which is about that what you can expect from the waste that had to be treated in Brazilian facilities. Nevertheless, this plant reaches a high efficiency of almost 29% at an ambient temperature of 20 degrees. We execute this project, as mentioned before, in cooperation with a local Turkish partner, which is responsible mainly for the civil works activities. And together, we are responsible for the erection of the equipment that we deliver to this plant. Another project, or actually 4 projects, are in Moscow, around Moscow. So we have 4 plants around Moscow. Waste is delivered via transfer stations to one of these facilities. All these plants are, no, sorry, 3 of these plants are in construction already. And the driver here was the strategic decision by the Russian government to have a certain amount of energy produced by renewable energy sources. Here in this project, we deliver the key technology, our process technology and key equipment to local partners, which then erect the plant and are responsible for the installation and commissioning of that plant. Another project, that is our first project in Australia, which we have contracted about a year ago. This project, the driver here was increasing landfill costs due to taxes. You see the numbers, quite high taxes. And here also we deliver chute to stack equipment, so the main process that I've presented before, and build it and erect it and commission it as an EPC consortium with joint responsibilities with a partner that has a local track record and has a strong local background. The last one, that is our newest project. It will be the biggest waste energy plant in the world, in Dubai. The erection construction work has started, means excavation and foundation and concrete pouring about half a year ago. It is the biggest plant contracted as a single contract with a capacity of up to 2 million tons per year, consisting of 5 units. And we, together with a partner here again, which has a strong local track record, are jointly responsible to build and operate this plant then for 35 years. Very important in this project was the economies of scale. This was very important to make that project feasible. So that's why so the size of it is really relevant. And of course, also the performance. You see here, even the ambient temperature, you can imagine Dubai is a very hot place. So we have 25% ambient, 25 degrees ambient temperature, a performance net efficiency of above 31 degrees. So I mentioned that I do not go into detail here, such the driver and enablers for this kind of project can be various. It can be a landfill tax that is increasing, it can be a landfill ban, it can be grants, subsidies from governments, and also some governmental support. As I mentioned, ECA covered financing is sometimes also very beneficial to make the financing possible. So this leads to the quite different revenue models. So in places where you have low gate fee, low electricity tariff, you need a big subsidy. In other places where you have the good electricity tariff, and the incomes come from electricity, it looks like this. In Europe, it's the other way around. Typically, 2/3 of the revenues are coming from the gate fee. Another project, the whole concession payment might cover the service and the energy production. So if you need to know more, please check our homepage. You will find a lot of information there. Thank you for your attention.